So we should start getting our hands dirty and calculate some double integrals. But first, I have good news. So all this talk about the cuboids, the limits when delta x, delta y go to 0, sounds very complicated, right? But if you remember in one dimensions, when you studied the Riemann sum as a limit and so on, it also sounded complicated, but eventually you did not use it, right? In practice, nobody does an integral using Riemann sums, unless you are a computer. If you want to do a computational integral, then absolutely you have to do Riemann sums. Yeah? But when we are in class calculating analytically an integral, you don't do any Riemann sum, you don't do any limit, you just calculate the integral. How do you do it? You find a function whose derivative is equal to whatever is inside the integral, and that is the result of the integral. Okay? This result, by the way, is called the fundamental theorem of calculus. It has a very big name, and let me add it here. So I have gone back to a revision of definite integrals. So let me add the fundamental theorem of calculus. And this theorem is really important because it's what allows us to actually do integrals analytically. Okay? So what does this theorem says? This theorem says that if you calculate this integral of a function between a and x with a variable limit x, okay? And remember, this was this concept of the area below the function between a and a variable x. So x can move, and therefore the area depends on x, okay? So the result of this function is another function, which is the integral that you are looking for. And it's a function of x because x is here on the limit. Yeah. But what is this function? Well, the fundamental theorem of calculus tells you that the derivative of the function I of x with respect to x is equal to f of x. I don't want to spend time explaining this because this is like fundamentals of integration, but I would really recommend you to think about this. Think in particular about this. Think about why this is. And the way to think about why this is to picture this integral of x as this area where the limit of x is changing. Yeah. So think about what happens when x changes by dx. How does the area change? And therefore, what is the rate of change of the area with respect to x? Why is it equal to f of x? Okay. So this is the fundamental theorem of calculus, and it means that when you want to solve an integral, you just need to think which function, when I do the derivative with respect to x, gives me the integrand. So you think backwards, and this is called, you think about an antiderivative, and the result is your integration here. Okay. And of course, you would then have to do between x equals a and x equals x. Okay. So this, by the way, is why you can also define the indefinite integral when you don't place any limits. And this is simply equal to I of x minus I of a, but I of a, now you are not making it explicit. So what is a? I don't know, anything. So I of a can be anything. And therefore what we do is we just call this plus c. Yeah, so that's what we call an indefinite integral. But we still know that the derivative of ix with respect to x is equal to f of x, because this is the fundamental theorem of calculus. So calculation of derivatives is simply finding, so calculation of integrals, in the end, is simply finding an antiderivative. That's what you did in one dimension, and that is what you will do in 2 dimensions doing double integrals. So you will do first an integral, finding an antiderivative of fxy. This will give you a function of y, of which you will find an antiderivative to do the integral on y. Okay, so let's get started with that.